ladies and gentlemen. Today we're going to be covering this concrete road patch, quick patch. Fast track pavements have become more and more popular over the last decade, and one of the obstacles with using concrete is that it takes time to go from that fluid state to the hardened state, as opposed to asphalt, which can go from that fluid state to that hardened state in a relatively short time as long as it cools. With concrete, it normally has to go through a certain set of thermokinetics and cement hydration to achieve enough strength for traffic to roll over it, especially heavier traffic. What we have done over the last decade or so is enhance the fast track pavement concept, which is opening up traffic with a concrete placement within 4 to 12 hours after said concrete has been placed. And the only way we've been able to do that is by using accelerators, in the past, that is. Now the problem with accelerators is that normally you had to put them on the job site and they were pretty fast to act. So calcium chloride accelerators thrown in the back of the truck as a flake, and you would have a very short window to get that concrete down the chute into the form, finished, closed up, or placed, finished, and closed up. So the concept that I'm talking about is retaining that workability with a 90-minute window, and then a short period of time after that, somewhere between 4 and 12 hours, you develop that strength. So the same as the fast track pavement of old, but now we're controlling that workability window and giving folks time to actually place it, finish, and close up that surface. So what we've got is, we've been doing this for a while. This is something that I specialized in, and we're going to walk you through not only the mix, which we went over in some detail, and it is 72 degrees in here, so we're actually going to be here with our mix design today, but we're actually going to walk through the lab with you today and show you the semi-adiabatic temperature device that we use to measure that heat of hydration over the 24 hours. Then we're going to be doing 2 mixes today. So the 2 mixes is one mix with just the type 1-2 Portland cement, the sand, the high range water reducer, and the water content. And the second mix is using these different chemistries and a little bit more chemistry to enhance that early strength. And what we're trying to achieve is somewhere between 1250 psi, really 2500 psi at 4 to 6 hours. And we're going to compare that to the reference. So you'll actually get to see what that chemistry does to enhance that thermokinetics and cement hydration to give us that early strength. So let's go ahead and take a look at that mix, and then we'll take a tour around the lab. You're awesome. Thanks again for joining us. We just got finished weighing up the mixes, and before we actually dive into mixing and making those samples, I wanted to give you a quick overview on the materials that we use, actually show them to you. And let's start off with the most basic. In our standard performing concrete, we have a combination of your ordinary Portland cement. Here we're using a type 2, and then for laboratory purposes we're using a concrete sand. Now again, that's for laboratory purposes. You're going to see the type of mixer that we're using. It really doesn't accommodate the 3/4 inch, 3/8 inch, but again here what we're trying to do is look at the hydrated cement matrix and tailor it for us to get those strengths that we're looking for. So with our standard mix, we're looking at a combination of our Portland cement, our sand, and of course our water. As well as for our standard performing mix, we're going to be using the water as well as the high range water reducer. And the high range water reducer is to get us a fluidity or a fresh property that is more convenient, allows the finishers to get the concrete down the chute into the formwork and finish really quick so they can get off that pavement and get it closed up with a blanket and let it start curing. When we go to our higher performing mix, with that first mix we're reaching 150 to 200 psi at the desired time. With our higher performing mix, we're going to combine an accelerator to get us that early strengths as well as those fresh properties, a hydration stabilizer which will hold back those accelerated thermokinetics of cement hydration and not only give us a longer workability time, that 90-minute to 120-minute window, but it's also going to increase the rate of cement dissolution and give us more bang for our buck. We call it the rubber band effect here. And then our last piece is a colloidal silica. Now this is a bell/whistle that I like to add, and we did this a few years ago, oh gosh, about 6 or 7 years ago now, when we did a fast track pavement up in the mountains of Colorado, and we've had no problems with it, especially within that deleterious environment with your freeze-thaw cycles and your de-icing salts, de-icing brines. So not only are we getting that fast track pavement, we're getting a durable concrete, and we're doing that with the addition of our colloidal silica. So that wraps it up. Excited to get into the mixing and making and then finally breaking. I just want to remind you that we did a scaled down version. So while this isn't a concrete mix design, these are the beginning steps that we would take to save our clients money but still give us the information that we needed to generate that information that we would eventually go from the bookcrete through the labcrete to the realcrete and started throwing that coarser aggregate. And we had a great time today. We went over what the concrete mix is going to look like, the raw materials, the combinations that we're using. And remember, that piggybacks with what we discussed many moons ago. And Patchouli will go ahead and throw that link into that concrete. That wasn't a Q&A, that was a formulation, that we did behind. So, okay, we're going to get into mixing and making this stuff. And again, the next video we're going to talk about the sequencing and why it's so important with these higher performing concrete mixes. So hope you enjoyed. If you got any concrete questions or concerns, throw them in the comments section below, or you can tell us about your own fast track pavement, because all of those fast track pavements are different and they have their own bells and whistles. We're excited to hear about it. Have an awesome day. Go concrete, beat asphalt.